So here is a problem from homework number 10 that was a request for me to create a video. We're looking at a rectangle bounded by the x-axis semicircle as shown in the figure. So a point is given to us on the circle, and that point is xy, and that's the intersection of the rectangle and the circle. So we want to find the dimension of the largest rectangle. So definitely, if the radius of the circle increases, that rectangle will also increase. So we know that if we create a triangle here, this triangle, let's say here, where this is the radius, r, yeah, and this is x and this is y. So we can say that using Pythagorean theorem, x squared plus y squared is equal to r squared. Yeah. And if we try to isolate y, we will minus x squared on both sides. That gives us y squared is equal to r squared minus x squared. And then if we take the square root of both sides, we'll get plus or minus the square root of r squared minus x squared. So y is equal to plus or minus the square root of r squared minus x squared. Now, because the semicircle is in the positive region only, right? Anything here is positive, then we don't need this negative here. So y is equal to the square root of r squared minus x squared. Okay. Now, so that's an equation of y. Now, in addition to that, we also know that the area, okay, of the rectangle. So if this is x and this is x, the area will be 2x times y, the length times the width. Okay, length times width. So what we can do now is replace y. Okay, so if we replace y, we have area is equal to 2x, and instead of y, we're going to write the square root of r squared minus x squared, okay, which can be written also as, instead of writing the square root, I can use exponential form, so that is 1/2. The reason I'm doing this is because I want to differentiate the rate. We want to differentiate the area. So we're differentiating the area because we want to look at the largest possible rectangle. Okay. So what is dA with respect to x, dA dx? Well, we'll have to use the product rule. Okay. So the derivative of this would be 2, and then the r squared minus x squared to the 1/2 power stays. Plus, now we take the derivative of the parentheses, so the 2x will stay. And then you will have to use the power rule, or the chain rule, I should say. So we have 1/2 r squared minus x squared to the 1/2 minus 1 times the derivative, so I'll write that here, times the derivative of the inside. Okay. Well, if you take the derivative of r squared with respect to x, right, that becomes 0. Okay, because you're going to get 2r. So this portion here will become really 0, right? Because it's 2r times dr dx minus the derivative of this portion here is just 2x. So finally we have dA dx is equal to 2 parentheses r squared minus x squared to the 1/2 power, plus if you multiply 2x times a half, that just becomes x. And then we have r squared minus x squared, and 1/2 minus 1 will be negative 1/2 times this minus 2x. So simplifying this again, we have dA dx is equal to 2 parentheses r squared minus x squared to the 1/2. This positive and this negative will become negative, and the x times the 2x becomes 2x squared, and we have r squared minus x squared to the negative 1/2 power. Our goal is to find the values of x, or the critical numbers. So if we simplify this even further, dA dx is equal to 2 parentheses r squared minus x squared to the 1/2 minus 2x squared over r squared minus x squared to positive 1/2. So now I'm going to make a common denominator, because this is like over 1, which is r squared minus x squared to the 1/2. So then this becomes 2 times r squared minus x squared, right? Because the 1/2 times the 1/2 becomes 1. And then here we have minus 2x squared. This is dA dx. Simplifying even further, we have 2r squared minus 2x squared minus 2x squared over r squared minus x squared to the 1/2 power. That's dA dx. Okay. And now I can set that equal to 0. Okay. So we have 2r squared minus 4x squared over r squared minus x squared to the 1/2, and that is equal to 0. So if we cross multiply now, the denominator times 0, this leaves me with 2r squared, okay, 2r squared minus 4x squared is equal to 0. Therefore, 2r squared is equal to 4x squared. And now we'll solve for x. So we can divide both sides by 2. That leaves me with r squared is equal to 2x squared. We'll divide both sides by 2 again, so r squared over 2 is equal to 2x squared over 2. So r squared over 2 is equal to x squared. And then we take the square root of both sides. Plus or minus. So we have plus or minus, this is really the square root of r squared over the square root of 2 is equal to x. So plus or minus r over root 2 is equal to x. Now, obviously, if you look at our picture, we're only looking for the positive value of x, positive, right? Because x is not negative in quadrant 1. So x is equal to r over the square root of 2. So here is my value of x. Okay. So now we can find y. Okay. If you recall, we had from above, y is equal to the square root of r squared minus x squared, right? That's what we got from when we started the problem, right? Here is our y. Okay. And we now have a value for x. So substitute x, which is equal to r over the square root of 2. So we have y is equal to the square root of r squared minus r over the square root of 2 quantity squared. So now we have y is equal to the square root of r squared minus r squared over 2. This is over 1 here, so we'll find the common denominator. So this becomes 2. So here we have 2r squared minus r squared. So y is equal to r squared over 2, the square root of that. And this can be simplified as the square root of r squared over the square root of 2. So y is equal to r over the square root of 2. Okay. So we have x and y. Okay. The question is asking us, find the dimension of the largest rectangle. So we want to find the dimension of the largest rectangle. Okay. Now, if you look back at our picture, okay, if you look back at the picture we have, supposed to be a circle. Okay. Close the circle. And somewhere here is the middle. Here is my rectangle that I'm looking at. Okay. So we know x is r over the square root of 2. And this is the x value here. Now this side here will be minus r over the square root of 2. So maybe I should write this closer here. This is r over the square root of 2. And the y value, this y value here is r over square root of 2 also. So the total length, this total length is r over the square root of 2 plus r over the square root of 2, which is equal to 2r over the square root of 2. And if you rationalize that, 2r over the square root of 2 multiplied by root 2 top and bottom, so this becomes 2 over 2 root 2 times r. The 2's cancel, so we have root 2 times r. So this is the length of the rectangle. And the width is r over square root of 2. So that's the dimension of my rectangle. Okay. I hope this was clear enough. So the only little detail that you have to be careful with is over here where we said it's the chain rule. So just be careful with that, okay? Because you have to take the power rule and then take the derivative of the inside with respect to x, and that's where this is coming from. But this part here will be times 0. So that goes away. Okay. Hope this is helpful.